When you translate KLMJ according to the rule x plus 6y minus 5, what is the equation of the line on which L prime M prime will lie? Ooh, that's a complicated one, huh? Should I zoom in a little bit? I don't know if I can. That zoomed in a tiny bit. So really, we're not worried about translating the whole quadrilateral, or rectangle rather, right? All we care about really is translating LM, because that's what we care about where it lands, right? So we're going to take LM and we're going to go to the right 6 and down 5. To the right 6 and down 5. So I translated LM for you guys. I translated it to the right 6 and down 5 to get L prime M prime. And now we need to write the equation of the line. Yay, Johan's first. X equals 1. Very good. The equation of that line is x equals 1. This line is intersecting the x-axis, and it's intersecting the x-axis exactly at 1, and so that is the equation of the line. Homework answers. Sorry, it's not the prettiest homework typing job we've ever done. But you get the idea. On that first one, I don't even think I didn't even translate it, but I did the other ones. Next page. These are the ones I like more, where you're actually thinking about where the figure is moving and coming up with the rules. Any questions about 5 through 12? This right here, you know, on the quiz, you're not going to have to be drawing a new figure because you submit your answers in a Google form. You're not going to be drawing anything on the quiz, but you will be answering things like this, like 5 through 12. So now's the time to ask if you're confused about any of those. Next page. On this one, just concentrate on the coordinates because, like I said, a couple of them we didn't even draw the picture. Now, on number 13, that one was kind of tricky. You had to reflect it over the line y equals x, and the figure mapped onto itself. It reflected and it overlapped. So you probably can't see that teal one too well, but that is the reflected figure, and it looks kind of weird. So make sure you look at the coordinates. Remember, the rule for when you reflect over the line y equals x is just you trade places. X, y becomes y, x. So negative 5, 1 becomes 1, negative 5. You don't change the signs of anything. Number 14 was different as well. On number 14, we weren't reflecting over the x-axis or the y-axis. You were reflecting over the line y equals 2. So that one you couldn't use a rule for. You just had to count how many away am I from y equals 2, and then I need to go that much more away from it on the other side. Okay, did you look at 13 and 14? Let's look at, like I said, we didn't graph 15 and 16 for y'all, but all we really care about are the coordinates. So check those. So the next and actually the last lesson of this unit is rotations. Tomorrow we will honestly review the last 2 days. We'll review and do an activity. Thursday we will do an assessment, and Friday we have our quiz over transformations. So let's talk about rotations today. Turn. A rotation is a turn, which every point is going to move in a circular path about a fixed point. And common rotations would be at amusement parks with our Ferris wheel, and I don't know what the swing thing is called. Yes, Abby, the DPM is a test grade, yeah. So, you were asking about counterclockwise or clockwise. In this class, in this unit, we are going to normally study counterclockwise rotations in increments of 90 degrees with the center at the origin. Is that the only rotations that exist? Absolutely not. But those are the 3 that we're going to focus on. We will ask you about other ones, but we will give you the skills to figure out how to do the other ones. But the ones we're going to focus on is 90 degrees at a time and counterclockwise. So counterclockwise means you're going in the opposite direction as the hand on the clock. From A to A prime, from A to A prime, from A to A prime. So we'll be doing 90 degrees counterclockwise, 180 degrees counterclockwise, and 270 degrees counterclockwise. Okay, so if your entire figure is in the first quadrant, if the whole figure's there, then when you rotate it 90 degrees, it'll end up in the second quadrant, 180 it'll end up in the third, and 270 it'll end up in the fourth. One quadrant for each increment. Now, every now and then, we might ask you about, like I said, a different rotation. Other rotations do exist. You don't have to rotate about the origin all the time. You don't have to go in increments of 90. But there's just a couple examples where we're rotating about the point A. We're not rotating about the origin. Just wanted to show you that they do exist, and that's what they would look like. Okay, so we are going to discover the rules for rotating counterclockwise in 90-degree increments. We're going to rotate Santa and his reindeer counterclockwise 90, 180, and 270 degrees. Okay, so we're going to pretend that gray thing is like a sheet of patty paper. Pretend like we all have patty paper. And how you would rotate it if you were using patty paper, which you don't need because I think that kind of babies you. Oh, he's going to fall out of the sleigh. Is that you would, if you were using patty paper, you would lay it on top of your coordinate plane and you would draw a cross at the origin. And then you would simply take your paper and rotate it 90 degrees, boop, and then you'd center it back at the origin again. So, real quick, we were supposed to first write down what the coordinates of A were. 1, 2, 3, 1, 2, 3, 4, 5. So the coordinates of A were 3, 5. What are the coordinates of A prime? Where did that dot land when I rotated Santa 90 degrees counterclockwise? -5, up 3. Awesome. Okay, let's do it again. 90 degrees more. Ready? Uh-oh, here we go. Gravity. Okay. Now, what are the coordinates of A double prime? I don't really like to call it A prime. This would be A double prime. -3, -5. And ready for 270 degree rotation. 270 degrees. And there we go. A triple prime. 1, 2, 3. What are the coordinates of A triple prime? You already knew it. Over 5, down 3. Huh. So this is going to enlighten us and tell us what the rules are for rotating counterclockwise. So, if I call this one X, Y, what would I call this next one? Well, this is -5, and 5 was Y's value, so that's -Y, and then X is 3, so that's just -YX. What would this one be if I look at the original? Well, that would be -X, comma, and then the 5, oh, -Y. And then what would this one be if I look at my original? That would be Y, and then -X. So those are our rules for rotating, and I have them on a nice pretty slide. Maybe, there we go. So if you're taking notes, you don't need to draw the pictures necessarily, but I do need you to write down the rotation and the rule that goes with it. The rotation and the rule that goes with it. The rotation and the rule that goes with it. Because these are 3 rules that you do have to memorize, along with the reflection rules from yesterday. I will give you a trick to memorize these. But for now, I'm letting you write them down, because it can get confusing. Was that -YX or was it Y -X? It's confusing. Do y'all need more time to write these down? Okay, here's where I'm going to kind of teach you how you can come up with these rules all by yourself. So if you notice, Every time that you go 90 degrees, you are trading places and making the first one negative. And then trading places and make the first one negative. And then trading places and then making the first one negative. So let's look at it. You start with x, y. Okay? I want you to switch places and make the first one negative. Check. Okay, now from this one, I want you to switch places and make the first one negative. Oh, matches. Okay, now from this one, let's switch places and make the first one negative, which would make it positive. Oh, that matches. And then if we go 360, we should be back to where we started. Switch places and make the first one negative, which makes it positive. So if you can just remember that, switch and make the first one negative, switch and make the first one negative, switch and make the first one negative, then you can come up with all the rules on your own, starting with x, y. So write it down. Write down switch and make the first one negative. You guys flatter me too much. We're going to skip drawing the triangle 3 times, but we are going to work with the coordinates, okay? So I'm going to do the 90 degree first. Remember, to rotate 90 degrees, you switch and make the first one negative. Or you can use the rule to help you out. So if this is A, then A prime would be switch places and make the first one negative. B prime would be switch places and make the first one negative. C prime would be switch places and make the first one negative. And then you would plot it and see what the triangle looks like from there. Okay, ready? 180. You can either use your 90 degree coordinates or you can use your ABC, because we know the rule for 180 is negative x, negative y. So you're really just changing the sign of everything. Negative 2, negative 1, negative 2, negative 5, negative 7, negative 1. Okay, 360, that's silly. We know that that's going to be exactly how it started. And then 270, the rule for that one is, so if I follow the rule, I would write y, and then I'd write the negative of x. And then I'm going to write y, which is 5, and then the negative of x, and then 1, and then the negative of x. Okay, we got it. Okay, now I'm going to call names. Ready? So I give you a coordinate. I want you to rotate it 270 degrees and tell me the resulting coordinate. Don't write it yet. Graham, you're up. What do you get when you rotate negative 4, 2, 270 degrees? Graham got negative 2, 4. So if you're having trouble with this, you just grab the rule for 270. 270 says y, negative x. So you grab y. Uh-oh. No, that's not right. Y, negative x. So you grab y and you put it here. And then you grab x and you make it negative and you put it there. Is that okay? Is that okay? Oh, my mouse is on the 2. So the answer is 2, 4, because the rule says y, comma, negative x. Next one. Okay, Chloe, you're up. Coordinate 1, 5, rotate it 90 degrees. Chloe, did you switch and make the first one negative? That's the easiest thing to do with 90. Yep. So very good. The rule says negative y, comma, x. And you got it. It's negative 5, 1. Very nice. Okay, next one. Edriel, you're up. So Edriel, on this one, you just grab your rule. The rule is y, negative x. So you grab y, and you don't do anything to it. And then negative x. So you take x and you make it negative. A negative negative 6 is a positive 6. So the answer is negative 9, 6. You have to follow the rules. The rule. These are the rules. Okay? Next one. Ganesh. Good. This is the easiest rule of them all. All you do is take both coordinates and change their sign. Negative x, negative y. So take x and make it negative, take y and make it negative, it becomes positive, and there we go, negative 7, 3. Good practice. Okay, now anything is fair game. These can be translations, they can be reflections, they can be rotations. I transformed them. You have to tell me what I did to the coordinate, okay? Alton, you're up. I'll give you a hint. It's from yesterday's lesson. Yeah, reflection over what? You do need to be specific. Remember from yesterday, when you reflect over the y-axis, you change the x. When you reflect over the x-axis, you change the y. It's the opposite. So in this one, I made the y negative, so that means I reflected over the x. Very good. Okay, Johan. It is not a 270 counterclockwise rotation because that one is y negative x, Johan. Okay. Karthik, yes, it's a translation, but you have to be. We're being more specific. You have to tell me where it's going. Yes, Karthik, for yours. Translation up 4. Very good. Abby, you're up. Next one. Very nice. This one is a 90-degree rotation. Rishi, next one. Got him, coach. You're doing the very next one. Translation where? You'll have to learn how to type really fast, huh? Eric, you're on deck. You're up next, Eric. Okay, I have to move on. Have to move on. Eric, you're up. Good job, Rishi. Sorry. Very good, Eric. This one is an 180-degree rotation. And Relina, reflection over the y-axis because we changed the x. Very good. Oops, O-V-E-R, pretend that's a V, Y. Very good. Okay, so go home and study those rules. Okay, real quick. Name the figures that would represent a rotation of figure 2. Let's just talk about it. Figure 4, right? Figure 1 even. Would figure 3 be a rotation of figure 2? No, that one wouldn't, right? Figure 8 would. Not figure 5. Figure 6 would be like a rotation and a translation. Okay. Name 2 figures that represent a translation. So a translation would occur between like figure 4 and figure 8. What else? Figure 1 and 5. Any other translations? 2 and 7 would not be a translation. Be careful. 2 does not slide into 7's spot. 6 and 1 would not be a translation, guys. A translation's a slide. You can't flip it or rotate it at all. Okay? Name the figures that represent a reflection of figure 6. So figure 6, a reflection would be figure 8. Get it? Figure 8. Figure 5. Figure 4 even. I think that's all. 4, 5, and 8 would all be a reflection of figure 6, just over different lines. Figure 3 would not be a reflection of figure 6. No. Would it, over that diagonal line? don't think so. Nope. Okay, a few more. What's the degree of rotation? Oh, this is new. What's the degree of rotation that maps M to Q? Ooh. So first we have to assume that that little sun is a regular polygon, not a regular polygon, but that all of those points are equidistant. We do have to assume that. We know that there's 360 degrees in a circle. And on this star, there's 1, 2, 3, 4, 5, 6, 7. There's 8 points. So every time you move from point to point, how many degrees do you move? 45. Very good. So if we're going to go counterclockwise, that would be 45 times 1, 2, 3, 4, 5. 45 times 5. How many degrees? 135? But it actually didn't tell us which way to go, so let's answer it with the clockwise answer as well. If we went clockwise, we'd do 45 times 1, 2, 3. 45 times 3. Oh my goodness. Sorry. So the first one we did right there, this was the clockwise one. And then 225, this 45 times 5 is 225. That's the counterclockwise one. So we have 2 answers because they were not specific enough with their question. Sorry. Oh, where did I put it? There we go. I don't think we need to talk about this, but to get from ABC to A prime, B prime, C prime, you would need to perform 2 transformations, right? Probably a rotation and then a translation. A turn and then a slide. Oh my goodness, I had a lot more slides than I thought. Okay, let's try to write the rule for each of these. 2 negative 2 becomes 0, 2. Sorry, yeah. So what is that? What happened? We did x minus 2. And then negative 2 became 2, so it would be negative y. And this note right here is to say, instead of doing y plus 4, you write the negative of the y. Okay. 11, 11 became 2, negative 10. So that would be x minus 9. And then, whoa, y minus 21. That okay? 21. Okay. What would this last one be? 4, negative 4 becomes negative 4. So in that one, you just write x. Nothing happened to x. And then 7 became negative 7. So that would be x negative y. That would be a reflection over the x-axis. The rest of them would be translations, right? Or a combo translation reflection. Yay! We finally made it to the end. Sorry, I told you it was a short lesson. It was longer.